Just let me know.
Of all the species to have ever lived, all but a tiny fraction have gone extinct. At some point in the future, the same fate will befall humanity. It may take centuries, it might take eons, but extinction is unavoidable. The future is fraught with uncertainty, and the apocalypse never seems too far away. Nearly 800,000 years ago, an approximately 1 kilometer wide asteroid collided with Earth. The crater has yet to be located, but fragments from the impact have been found scattered across the eastern hemisphere, an expansive strewn field that covers up to 30% of the planet's surface. Our distant ancestors were not only alive to witness this event, but managed to adapt and survive. Impacts of this magnitude occur roughly once every 500,000 to 2 million years. More devastating impacts, like the one that nearly wiped out the dinosaurs, are far less frequent, possibly striking once every 100 million years. Whether a collision of this magnitude is survivable is a matter of debate. The kinetic energy released upon impact would be equivalent to the simultaneous detonation of billions of atomic bombs. Those who survived the initial blast would be subjected to unrelenting earthquakes, firestorms, and tsunamis. A thick layer of smoke and dust would quickly envelop the globe and blot out the sun. An impact winter that could last for months or even years. Darkness, freezing cold, and global famine would throw the world into chaos. In spite of this, long-term survival is not inconceivable. Small pockets of humanity may take refuge underground and would at least be given a chance to rebuild civilization. But make no mistake, it would be a close call. The survivability of an impact also depends on how much time we have to prepare. More than 90% of nearby asteroids and comets larger than 1 kilometer have already been detected. If one of them were on a collision course with Earth, we'd know for decades or even centuries in advance. But this was not always the case. In 1983, a 9-kilometer wide comet was only spotted 2 weeks prior to its closest approach. That's 2 weeks of preparation had it been aiming for Earth. While things have significantly improved since 1983, space is impossibly vast. In 2019, an asteroid capable of leveling a city was detected a day before it flew 5 times closer to the Earth than the Moon. While the odds of an extinction-level collision are remote, it's not impossible. There is a class of objects known as Damocloids. Damocloids are typified by their highly eccentric orbits and low reflectivity, meaning they periodically pay us a visit and are extremely difficult to detect. We're currently tracking about 200, but there could be hundreds more tumbling through the solar system. Damocloids are, on average, 16 kilometers wide. If one of them were on a collision course with Earth, there might not be any warning. when massive stars die, they explode. If a star went supernova within 30 light-years of Earth, it would be cause for concern. Fortunately, more than 90% of the stars within this bubble have already been discovered, none of which are at risk of exploding anytime soon. But some supernovae can still pose a threat from thousands of light-years away. It's a gamma-ray burst, produced by only the most violent explosions in the universe. Instead of a spherical blast, a gamma-ray burst will channel the explosion into two highly concentrated beams. More energy is released in a few seconds than the sun will radiate in its entire lifetime. The biological effects of a nearby supernova or gamma-ray burst are poorly understood. We do know that the atmosphere would absorb much of the high-energy radiation, but this may also strip the Earth of its protective layer of ozone. If so, harmful levels of ultraviolet radiation from the sun would penetrate down to the surface. Certain chemical reactions may also darken the sky and induce global cooling, a cosmic winter of sorts. This could last for years and would be lethal to many plants and animals. In fact, a gamma-ray burst might be responsible for a mass extinction that killed roughly 70% of all marine species nearly 500 million years ago. Now, humanity could easily protect itself against ultraviolet sun rays, but living through a mass extinction would not be a pleasant experience. While some authors have painted a far bleaker image, with one hemisphere effectively sterilized by intense radiation, these findings have been contested in recent years. The latest research identifies ozone depletion as the primary threat. Nevertheless, a gamma-ray burst sniping the Earth from across the galaxy is extremely improbable. All of them have so far been extragalactic in origin, much too distant to pose a threat. While there are a few potential candidates within the Milky Way, none of them appear to be directed at Earth. Apart from impact events and stellar explosions, the foreseeable future is free of cosmic threats. Other eventualities are either too improbable or won't happen for millions of years. Ample time for us to prepare, other calamities permitting. Around 74,000 years ago, a large volcano erupted in Southeast Asia. It is the most powerful volcanic eruption in human history. For up to 2 weeks, it spewed enormous quantities of ash and dust into the atmosphere, enough to block out the sun and potentially cool the planet. A volcanic winter. But there's great uncertainty about the effects of the eruption on both the climate and humanity. It ranges from severe to mild, with the latest research supporting the latter. In either case, this is good news. It means that supervolcanic eruptions pose little to no threat to human existence. After all, if early humans stood a chance, then so should we. But there is something even more destructive than supervolcanic eruptions. It's known as a flood basalt event. The largest one occurred 250 million years ago. An enormous outpouring of molten rock covered a region of Siberia the size of Europe. And it just so happens to coincide with the deadliest mass extinction in history. The good news is, flood basalt events are both rare and slow. Instead of a singular event, it's a series of eruptions taking place over thousands or even millions of years. As such, even if one began tomorrow, it might just be slow enough for us to adapt and survive. Throughout the centuries, pandemics have exacted a heavy toll on humankind. Among the worst was the Black Death. In less than a decade, it killed between 25 and 60% of the European population. The total death count is unknown, at least tens of millions. The Colombian exchange of diseases and the Spanish flu claimed the lives of many millions more. The tragedy of these pandemics and epidemics notwithstanding, they never came close to extinction. None of them killed more than a few percent of the global population. For instance, the Spanish flu infected nearly 1/3 of humanity, yet the vast majority of cases did not result in death. A pathogen that not only infects but also kills every single member of a species is difficult to imagine. In fact, there are very few examples of infectious disease driving a species to extinction. With that being said, it's not inconceivable. For instance, pathogens that can pass between multiple species can be far deadlier than those limited to just one. The H5N1 avian influenza, also known as the bird flu, is one such virus. So far, it's transmissible between humans and birds, but it can't sustainably spread among humans. However, laboratory experiments have shown that it may eventually acquire this ability through natural mutations. If so, it could easily become the worst pandemic in human history. But even this horrifying proposition does not come close to extinction. In a worst-case scenario, most of humanity would still survive. Pandemics are complicated. It's a topic that's more relevant now than ever before and cannot possibly be done justice in a few short minutes. But in the narrow context of human extinction, it seems unlikely for nature to stumble upon that perfect storm. Apart from volcanic eruptions and natural pandemics, the Earth has no inherent means of eradicating the human race. No other form of natural calamity is powerful enough to threaten our existence. As such, the most immediate threat to humanity has for a long time been, and continues to be, humanity.